Hello, in this tutorial we are going to cover how to generate open world landscapes inside of Unreal Engine. We're going to cover all the settings that go into actually building a landscape, how to build landscapes of specific sizes, import height maps to drive the shape of those landscapes, and also what exactly are landscape partitioning and how to set up different landscape regions to control when certain areas of your landscape and the assets on them load and unload when you're building open world environments. We have a lot to cover, so let's get into it. First things first is we're going to go ahead and make a new level that is set up to work with these open world tools. So I'll come up to the file drop down and choose new level. There's two main categories here to the levels that we could load. First is the basic kind that you're probably more familiar with, and an empty version of that, which is just a standard map inside your level. Next, we have our open world and our empty open world option. These will basically just create a new level, but they'll have a bunch of settings enabled that will make it easier for us to set up the open world stuff that we need to set up in order to have our landscape load and unload regions and so on. So we're going to choose an empty open world, and because I'm going to go ahead and create a new landscape based on a height map. So we'll go ahead and choose that and hit create, and I will save the map I'm in right now. Okay, so we have an empty level here, and I'm going to go ahead and make a landscape. We'll come up to the drop down the top left corner and choose landscape. Now I know these landscape settings are confusing, but I'm going to do my best to break them down, and hopefully you'll understand a little bit better what each of these numbers mean when we're talking about our landscape, and then as well these other numbers up here that represent how we separate our landscape into chunks to load them in an open world. So first, let's come down here to section, components, number of components, overall resolution, blah, blah. What does all these numbers mean? The anatomy of a landscape is basically this. We have quads, which are these littlest squares here, which represent the smallest pieces that make up a larger landscape. If we're talking about a mesh, you can imagine it's like a mesh that has vertices that are connected by edges that create faces, and that's how you have a mesh. So that's pretty similar to a mesh here with these quads. These are just little squares that make up the surface of the landscape. But those quads make up a slightly larger thing called a section. And that section, either one or two sections, will be used to make a component. So we have components, sections, quads. These little green dots here are quads. Then we have sections up here, which is a larger square. And then we have components. So we can see here, if we come to sections per component, this option, and we switch it to 2 sections, now you can see we have these dark green, which represent our quads, this slightly lighter green, which represent a section, because now we're 2 by 2. So we have 2 sections here. And then we have this lighter green line here, which represents our component. So that's basically the organization. These are nested kind of ways of subdividing the mesh, or the landscape in this case. So quads make up sections, and then depending on how many sections we choose here, those make up a component. And the component is the basic square that makes up our landscapes, that we have multiple components in a row, and that makes up a landscape, right? So we can see here, if we choose 8 components by 8 components, we have 8 of those squares making up each. We have 8 by 8 components making up this landscape. If we come here to the section size, understanding this about how the landscape is built, we come here to section size and we choose 7 quads now, and we also, let's drop our sections down to 1 section per component, so it's a little bit easier to see. So now you can see we have 1, 2, 3, 4, 5, 6, 7 quads, 7 by 7 quads making up each section. And then we have 1 section making up a component. And then we have 8 of those components in a row in each direction. And if we drop the number of components down, now we have 1 component, 1 section with 8 quads by 8 quads. And if we had 2 sections, now we have 4 of those squares, 2 by 2 sections of 7 quads rather, 7 by 7. So if we increase it up to 31 quads, I think you're starting to get the idea. Now we have 4 sections, each made up of 31 by 31 quads, making up 1 total component. And then if we increase those component number, then it'll spread it across our landscape. So just to review, we have quads, little squares, making up a section. That section then makes up a component, and that usually we have 2 options here, either to make it up by 2 sections across, so 4 sections making up a component, or 1 section across, making up 1 section per component. That's what these numbers mean. Now, what does that actually mean for you as you're making it a landscape? Because I mean, these are great. Now we know how those make up a landscape, but why would you choose which and which situation? Basically, they come down to the quads, which are basically the mesh surface of your landscape. And then we have these ways that data is added together or chopped up so that it can be loaded and unloaded in memory, right? When we look down here and we see our total number of components, we want a good number of components that's easy for the computer to run, but that still has the resolution that we need to make our landscape. Now, this brings us to overall resolution. The overall resolution is in meters. It's not like the resolution of your landscape, it's the size of your landscape, which is a little confusing. So right now we have a 500 by 500 meter landscape. If we increase the number of components here, we create a 4,000 meter by 7,000 meter, which is 4 kilometers by 7 kilometers. If we wanted a 1 kilometer by 1 kilometer landscape, we would just drop the number of components down here until we got about an overall resolution here of 1,000 by 1,000, which would create a 1 kilometer by 1 kilometer landscape. So we have the size of the landscape we want to make. We have the quads that make up a section, that make up a component, and the number of components we need to create the size of our landscape. So how do we know what numbers to enter here? Because we could, create an overall resolution of 1 kilometer by 1 kilometer, but that could be made up by different numbers of quads, right? We could have 7 quads by 7 quads per section. That would create pretty much also 1 kilometer by 1 kilometer square, right? Or we could use 255 quads per section, and that would be, we wouldn't need as many components, but we could still make a 1,000 by 1,000 kilometer area. How do you know if you should use more quads or less quads to create the same size landscape? This comes down to the efficiency of the landscape. It comes down to the math that's used to store this landscape in memory and chop it up and load it. There are actually some guidelines that Epic Games has released that tell us the optimal quads and sections to give our landscape that will result in the right number of components here for the landscape to be efficiently loaded. So we can go ahead and open up the landscape technical guide, which I will go ahead and link below this tutorial. And this gives us guidelines based on the size of the landscape that we want to generate. What are the most efficient way, number of quads, number of sections, number of components to get that size landscape, but in an efficient manner. We'll come down here to our recommended landscape sizes. And here we can see that, remember this is in meters. So here is a 4 kilometer by 4 kilometer size landscape. And these are the recommended settings for creating that size of landscape. Now you can create higher than this amount, and I will put a little calculation for you below this tutorial as well that will help you generate those larger sizes. And maybe we'll cover this in another video as well if we want to cover how to create larger than 8 kilometers. But for purposes of this tutorial, I'm just going to stick with these general sizes, and we will go ahead and make a 4 kilometer by 4 kilometer square landscape. So first thing we come to here is quad sections. So this is the number of quads that would make up a section. So it's telling us the most efficient number of quads when creating a 4 kilometer landscape is 63. So we'll come over here to the number of quads and switch it to 63 quads. Next, we will come back here and come to the section components, and it's saying having a component with 2 sections, 2 by 2 sections in it is the most efficient for this size. So we'll come over here to the sections per component and switch it to 2 by 2. Next, we come to the landscape component size and total landscape components. These are a little confusing. The number we want to look at is the second one, total landscape components, and this is the number we want to enter, 32 by 32, which is what we enter in here as number of components. So if we enter 32 components by 32 components, you can see that expands our landscape there. And we arrive at an overall resolution of 4,000 meters by 4,000 meters or 4 kilometers by 4 kilometers. And the total number of components that we're getting that make up that landscape are 1,024. which is a more efficient number of components to generate the same size landscape as if we use a different number of quads. That is the recommended settings. Reference this sheet whenever you're creating a landscape, and it will tell you based on the size of the landscape you want to generate, what are the settings you should enter. If you're getting a lot out of this video and you've gotten a lot out of my other videos, you might be interested in something that I recently launched called Aziel Art Academy. It's for those of you who are tired of sifting through YouTube videos to try to piece together all the information you need to get good at environment art with Unreal Engine. It basically takes all my courses and combines it with coaching and a private group where you can get all of your questions answered. If this seems like something that you might be interested in and you're looking for more personal attention and support in your Unreal Engine journey, this might be something for you. If you're interested, check out the link in the description below this video. Let's get back to the tutorial. So now that I've created the landscape size using the number of quads that I need, now it's time to look at the actual world partitioning settings, which is how we chop this landscape up and load it based on where we are as a partitioned section, which is what we do in open world setups. So here under the partition grid size, this is a pretty important number. This number is basically how many components are going to make up each little streamable section. We could drop it down to one component per, I think it calls them streaming proxies. So basically how many, should we take every single component and make it a streaming proxy? Basically a little square that could be loaded and unloaded, or should we create it every second component or every fifth component? I think if you have a less experience with creating these kind of landscapes, I would recommend keeping it at 2. This will create 2 components by 2 components for each partition grid size, which is represented by this yellow square. If you're wondering what the yellow square represents, that's what it is. It's the partitioned size of our section. So we got our landscape and now we're cutting it up into these little squares we can load and unload, and that's how we define how big those squares are. Now we have our region size, our world partition region size, which is how many of these partition things, these little partition squares that we've now denoted, how many of them are in a region that we can load as a chunk, because it's not very efficient to just completely just load all of these partition grid sizes as we go. We kind of want to load them in packages, and so this helps us define how many packages we will end up with, but based on how many of these partitions go into each package. I recommend playing with these numbers a little bit, but I will show you also in a minute how we can actually adjust these partition regions ourselves. If we go ahead and hit create here, and it's going to prompt us to save our level here, and so we'll go ahead and save it into a new level, and then we'll let it generate, which might take a minute or 2. All right, so when our new level is finished, our landscape rather is finished processing, we will be left with a new blank level because now it's completely unloaded. It's created the landscape, but everything is now not loaded because it's now created as a partitioned landscape. And if we expand our partitioned landscape here, we can see that we've created all of these proxies here. And if you remember, basically when we were choosing the components, how many components go into a proxy, that first number at the top there, that is how we determine how many of these proxies we generate. That is how our landscape is separated. And then we have our regions here, which was our second number. So if we switch off of our landscape here, and we come over to our world partitioned window. And if you don't see this by default, you can find it by coming up to window and coming to world partition and choosing world partition editor. When you click on that, this little window will show up. And this is how we manually load and unload regions in our world. You can see we've made these different regions which contain a certain number of proxies, which in turn contain a certain number of components and sections, which are made up by quads. So now you can see everything together. This region here, if I click on it and I right click and I choose load section, it will load that little square of landscape, which is pretty cool. And I can load this other one over here as well, and this one by right clicking on it. And if I want to unload it, I can right click on it and unload selected regions. So pretty neat. Now, let's go ahead and load in our height map for our landscape. So I'll go ahead and load all of my regions here. You don't necessarily have to load all your regions, but you'll see in a minute why it can be visually helpful to see your full landscape when you're importing your height map, just to make sure that it's expanding correctly over your landscape. So we'll have these loaded here, and we'll come over and choose our landscape tools again. We'll come over to the manage section and choose import. Now, the reason we didn't import the height map at the first step was because when you're processing a really large landscape for the first time and you're loading a height map at the same time, it can sometimes be more prone to crashing or more prone to being too much data for the computer to handle at once. So it can be a more efficient workflow to first generate your landscape with its partitions and all this stuff, and then come in here and actually load the height map for it. So now we're going to do that. So I'm going to come over here under import, we're going to choose height map file, and under the three dots here, we're going to choose the height map, which is really just a black and white texture. So white areas of the texture are high and darker areas are low. I will link below this tutorial a website to get a bunch of free height maps for that you can download and use in this fashion. So we'll go ahead and choose open. So next we want to look at the import type here. By default, it's going to be original here, probably. And what this is going to be basically what is the resolution of your height map that you're using. If it's a 2K by 2K resolution height map, then it would line up perfectly with a 2K by 2K landscape. But since we're making a 4K by 4K landscape, like this one, it's not going to load up exactly the right size. It's going to be, half the width, as you might imagine 2K is. So we can expand the texture to fill the whole 4K landscape. That's perfectly fine, but we'll need to come up here to the import type here and choose either expand, which will just try to expand it over the landscape, or resample, which I've found to be the best results here. So it's going to resample the texture into a larger size and then use that to define the height of the landscape. So once we've done that, you can see that that texture representation of where the texture is going to be placed is expanded to fill our whole landscape. Now, if we go ahead and hit import, it's going to tell us a little error here. Import size is 2K and the landscape is 4K. We know that, so we'll go ahead and hit OK. And now we have gone ahead and loaded our height map. So I'll go ahead and switch off of my view here, and we can't really see what's going on because we have no lights. So let's go ahead and make some lights. Choose the environment light mixture. We'll create some sky atmosphere. I won't create clouds or fog yet because it's a little easier to see what's going on with a big landscape like this. So now I have a huge 4 kilometer by 4 kilometer landscape here with a height map, which is awesome. I'm going to go ahead and add a little bit more height to this landscape by coming over to the details panel and choosing my landscape here and upping to 200 here. Perfect. Okay, so we have our landscape, and now let's talk about how this actual word partitioning works. As I mentioned, we have our landscape divided into components, and those components you can see here are divided into these little smaller squares, which are our proxies. Those were the proxies when we created our landscape. When we chose that first number, how many proxies create our landscape, that is these squares. And if we go ahead, we can actually click on those squares on the landscape. So if you're curious how many are sort of making up the landscape here, and on the right side, we can see that those are being selected here under our landscape here under the streaming proxy. But right now, they are all going to be loaded in the size of these larger regions. So basically, if I'm over here and I run up to this region, it's going to load this entire region at once. And so sometimes this is good, this is what you want, but sometimes you might realize, oh, okay, I actually created regions that were too big. We can actually go ahead and rework the regions for our landscape by creating a new set of volumes that will represent how we unload and load certain areas. And these don't have to be necessarily in grids, which is a good thing to mention. Like, these will be volumes that we can position, and basically everything in that volume will be loaded or unloaded when we get close to it. So it's a really great way to either in a grid system or organically kind of separate your level into sections that can be loaded or unloaded. So I'm going to come over to these landscape regions here. And if we scroll up here, we can see the landscape region here is at the top under our landscape. If we expand our landscape, if I go ahead here and we delete these, you can see they are removed from our world partition view. We can go ahead and make new ones. So if we come and choose our plus button here and we choose volume, and we come down here to location volume here. This is the volume that we want, location volume. And I drag this in and we come to our details panel here, and we'll expand this to be like 100 by 100 by 100. Actually, let's make it a little bit bigger. Let's make it 500 by 500. Okay, and we'll move this over here, and we'll go ahead and duplicate this over and make a few of them to encompass our landscape. And then I can come and drag this over here to duplicate them again. Now we've created some new world partition regions. So the thing I need to do to get these to work is select all of them, and then we want to go ahead and click and add them underneath the actual landscape asset here. So if we click and drag them on top of the landscape, it's going to put them underneath this landscape here, so it knows it's related to them. Then we need to actually go ahead and reopen our level to get these to work. So if I go and double click on my map and we save everything, now we're reopened and we can come back into the world partition, and now we have all these beautiful regions that we can load or unload as needed. So I can just load this little section here or this little section. Beautiful. So this is when we're working on assets here. Let's go ahead and add an asset. Like if we go ahead and go and grab a mesh or maybe a house. If I go and put a house here, and we'll make it really large. These are giant houses, just to make it obvious. So in this area of landscape, I have this house, and in this one, I have another house over here. And we go ahead and reopen our map again. Now, if I come here and unload this particular region, the house that was located on that volume there will unload, and same with this one. You do have to reopen your map because it kind of loads all the data and makes sure it's connected on the load of your map. So if you've added things to your maps and you're not sure why they're not unloading or loading, just make sure you reopen your level and then it should work. But now I can reload these regions and all the objects on top of it, be that objects or PCG, they will all load accordingly. So let's talk about not just when we're working in our viewport here, but what if we are wanting to play through our character and have these load and unload from our character's perspective. So if we come here and let's go ahead and come over to our world settings here, which again can be accessed by our tools, or rather our Windows drop down and world settings. Under world settings, under our world partition setup area, we can expand that. And we want to come here to our runtime settings. This is how we're going to determine at runtime how different areas of our open world will be loaded and the distance that they should be loaded, right? Here we have two different ways, or rather hashes, for the data that we could use. The old one is the runtime hash set, and the new is the spatial hash. I recommend using the spatial hash because it is a newer version it's a newer updated type of calculation type for doing these runtime distance calculations. So I recommend choosing that as the option you use, but you could experiment with both. Next, we have our preview grid. This is really the visual for us for how different things will load and at what distance. So if we go and choose preview grid on, now we can see that we have a grid, and basically everything that is part of this distance of this grid will be loaded, and everything that's outside of that grid will be unloaded, right? So if we go and we increase the loading range, that will go ahead and load different things in the distance. So let me go ahead and hit play here. So you can see it hasn't loaded all of our landscape here, but it's loaded quite a bit into the distance because we increased our loading range. But if I go ahead, decrease my loading range till just this area, and then we go ahead and hit play, it will not load that area of landscape directly over there. So it's kind of looking and seeing what we're close and loading based on this loading range that we've defined here under the grids. So if I go ahead and I creep up here on the edge of my landscape, it will go ahead and start loading that region. If I come over to this region, it'll start loading that region. And remember, the size of the area that you're loading is based on the volumes here that we set up. That's pretty cool. Basically, the cell size is these little squares that make up the volume that surrounds you as you're running around through your level. If I come over here and I lower the cell size, it's going to create some smaller squares that make up a more rounded shape. And if I increase the cell size up higher, it's going to create just much more of a blocky, large loading range. So that is what makes up basically the sphere around you that will load and unload things as part of your partitioned world. And then the range here is how far away they are loaded. As you might imagine, when you're actually creating your game, you probably want to have this load range be pretty large because you don't necessarily want mountains popping in and out directly in front of you. So if we go and increase our loading range here, and then we go ahead and hit play, that will go ahead and load a much larger region. And then if we go ahead and we add exponential height fog in, this will usually block out the far distant mountains and allow us to load them in or out depending on how far away from them we are. If you found this video helpful, I would appreciate a thumbs up or a comment. If you have any questions, like I said, if you're interested in joining the Academy, getting access to the private group, personalized tutorials, and all my courses in one place, check out the link in the description. I will see you in the next one.